Hello everyone. Today I am going to explain about the mesh analysis. This mesh analysis is very important to find the current at one point, voltage, power, etc. Today, for explanation, I am going to taking a circuit like this. Here Z1, Z2, Z3, Z4 are the impedances. Why I am taking like this means here there is any component resistor, capacitor, inductor, etc. Here there is a voltage source. Now we are going to write write how the equations are going to write. First of all, take the current direction in two loops as you like. Remember this, as you like. Take current directions in two loops. Now we are going to write KVL and the first loop, positive, negative, positive, negative. So V is equal to Z1 impedance and current flowing this is I1 plus Z2. Here in the case of Z2, current I1 is flowing from positive to negative, I2 is flowing from negative to positive. So write it as I1 minus I2. That's it. It is first equation. And in the second equation, here there is a Z3. Positive to negative, positive to negative. Current flowing from positive to negative. There is no voltage source, so you are taking as 0. Z3 into I2 plus Z4 into I2, and here is a negative to positive minus I1 minus I2 into Z2. It is a second equation. Now we are going to write V as simply Z1 I1 plus Z2 into I1 minus I2, and second equation as I2 is common the I2 term, then I2 into Z3 plus Z4 minus I1 minus I2 into Z2. Here there is a I2 also. That's why we are writing I2 into Z3 plus Z4 plus Z2 minus I1 into Z2. So from the third and fourth equations, we are writing a matrix 0, I1, I2, finding variables Z1, Z2, minus Z2 Z3 plus Z4 plus Z2. From the equation 4 and 3 we are writing these. So by using matrix solving matrix solvings we are finding how much current I1 flowing and how much current I2 flowing in the circuit. If the Z1 is a resistor, then we are simply writing R. Z2 is a resistor, Z2 is a capacitor, then we are simply writing 1 by j omega c. Then Z4 is an inductor, then we are writing j omega L. So finally in this way we are writing the equations and how the solution is finding. Remember these I1 and I2 directions are take as you like. If the current source is there also, you can write the current source voltage drop across the current source. If there is a voltage or current source in the second loop, then that is also mentioned in the place of 0. If the two components are present like R1C, then Z is equal to R1 plus 1 by K omega C. Similarly, inductance also. Just we are applying in KVL in two loops. If there are three loops, then we are applying KVL in three loops. That's it for today. Thank you everyone.